Hello, Professor Fraenkel. We wanted to interview about NIM. What do you like about NIM?
I like about NIM various things. For example, it's very easy to describe. It's also easy to win. As its Hebrew name implies, because Nim in Hebrew means to doze, and you can win while dozing. It's so easy. On the other hand, from a theoretical point of view, it's important because a very large class of other combinatorial games are equivalent to NIM in some certain mathematical sense.
Why is it important to study NIM? Does it help solve problems?
What is important about NIM is that it provides an introduction to the whole theory of combinatorial games. In particular, it provides the important strategy of converting numbers to binary and adding them in a fashion that's called NIM-sum, that is to say, ordinary addition, but like you do in kindergarten. You forget the carries from one stage to another one. And this also provides a key to many other games. This theory of NIM-sum is important in many other combinatorial games.
What NIM game do you like?
I like the game that's called Whitehove's NIM, which was invented over 100 years ago. It's played on two piles, and you can take from either pile like in NIM, but you can also take from both piles if you take the same number of tokens from both piles. It's interesting because there are still quite a few open problems in formulating the strategy of this game. Another interesting game is what we call Nimania. It's essentially NIM, but at move number k, you adjoin k copies of the present situation of the game to the game, and you play in one of those copies. And it has an easy winning strategy, but it takes so long that it's impossible to describe how long it takes by ordinary numbers, and so the winner cannot really consummate his win.
What does a mathematician do?
A mathematician is a gate opener. He provides the key to all the other natural sciences and beyond. Every really important theory in the natural sciences today has to use mathematics in order to make any kind of progress. That reminds me of Eugene Higner, the Nobel Prize winning physicist who wrote over 50 years ago an article about the unreasonable effectiveness of mathematics in the natural sciences.
Do you have a message for math by mail?
Be curious and inquisitive, and get some help from the internet. For example, the math correspondence at the Davidson Institute of the Weizmann Institute of Science, in order to get challenging new problems in mathematics. And so if you start and do that from an early age on, you'll become a big mathematician.
Thank you very much.
You're most welcome.